it's important to respectfully acknowledge the history, spirituality, culture, and rights of all First Nations, Métis, and Inuit peoples from coast to coast to coast, who have called this land home since time immemorial, and who continue to experience the ongoing effects of colonialism and systemic racism. This acknowledgement is nothing without action to back it up, and I encourage everyone to consider how we can each, in our own way, actively honor and uphold our obligations in a spirit of true reconciliation. After all, we're all treaty people. So, for those of you who don't know me, and I think I've introduced myself, or you know me, Laura Brinklow from the Institute of Island Studies, Chair of the Executive Committee of the Institute, and Coordinator of the Master of Arts in Island Studies program. So the Institute of Island Studies is a research, education, and public policy institute based just down the hall on the way to the washrooms, which are on the left. If you go around the corner, you're not too far. You can learn more about what we do by checking out our website, which is islandstudies.com, or our social media accounts. We also have a monthly newsletter, so if you're not already subscribed, here's a sign-up sheet. I'll send it around in a minute. If you've already receiving our newsletters, you don't need to. I'm not taking attendance. We just like you to add your email address if you'd like to get it, and that will include notices of further lectures. And we promise not to sell your information to the highest bidder. So I'd like to recognize a few people in the audience this evening. We have a couple of Mays students here, Master of Arts and Island Studies students, Barbara and Byron. Byron's about to graduate this year, FBA, if all goes according to plan. And we have the former director of the Institute, or not director, but rather the chair of the Institute of Island Studies and coordinator of the Mays program, and professor emeritus is Jim Randall. He used to be the one who would be up here talking
about... Former.
I know, I'm coming to her. Yeah, and so Jim is very happy in his retirement, although we keep him busy from time to time doing little research projects for us. Proper thing, yes. I'd also like to introduce Dr. Desheng Zhang, who is right here in the blue, and he's our visiting scholar. I think we started corresponding a couple of years ago after you met Jim in Hainan about coming here from Hainan Island, which is our sister island in China, and Prince Edward Islands, and so he's here from University of Hainan, and he's going to be here for the year undertaking research on agricultural economics on islands. So already we're making connections here and would like to continue that. And I'm hoping to convince him to give a lecture for us in the fall. We'll talk. Okay. No pressure. All right. So now I'll introduce you to Dr. Irené Novaczek, who needs no introduction, but you know, because that's my job. As you mentioned, yes, she is the former director of the Institute of Island Studies. When did you start? Was it 2001?
2004 to 2014.
Okay. Yeah, so 10, 9, yeah, that was a good time. She's a graduate of the Marine Studies program at University of the South Pacific in Fiji. And after she left here with us, she went on to become a senior research scientist from the Department of Fisheries and Oceans, and was there from 2014 to 2019. Okie dokie. Have to make sure I get it right. There she led a research and ecosystem restoration project at Basin Head Marine Protected Area in eastern PEI. Over the years, as an adjunct professor in the Mays program, she has supervised several Mays students and is currently on the supervisory committee for Marlene Chapman, whose work is on the lobster fishery in Prince Edward Island. And in addition to running her company, Oceana Sea Plants, she's now mayor of Berdolph. And congratulations, Your Worship. So tonight we get to hear about her work at Basin Head, researching a unique strain of Irish moss, Chondrus crispus.
Chondrus crispus.
Of course, Chondrus. I should have checked beforehand. Anyway, thank you, Irene. Take it away.
Thank you very much. Now, I had to step away from Fisheries and Oceans because they told me that if they kept me for another year, they'd have to hire me on full-time permanent. They didn't have the money. But they gave the money to Surrey Wildlife, and they hired me. Not as a full-time, all-year-round person, but just as the field director for the summer. So in fact, I've only just stepped away from that position with with Surrey Wildlife. As of last summer, I was still in the field up in Basin Head. And hence, I've identified myself as the marine ecologist for Surrey and area branch of the PEI Wildlife Federation, for whom I have been working in recent years. And this is a drone photo of the estuary as it was in, I believe, 2015. About 4,000 years ago, this was a freshwater system. And as far as we can tell from core samples and the inspection of diatom frustrules in deep cores from the main basin, which this is the northeast arm, the main basin is a deeper part is there, and the outlet to the sea is over to the left of the top of the picture. Somewhere around 1,000 years ago, as the sea levels rose, then the system was inundated with seawater. So sometime in that last 1,000 years, Basin Head became populated with a kind of Chondrus crispus, or Irish moss, that is very, very different from what you will find if you go to the shore anywhere else on Prince Edward Island or anywhere else in the world, in fact. We call it the giant moss. Louis Hannett, well, it was initially noticed by a provincial biologist, who then turned to Louis, who was the phycologist at UPEI at that time, to try to identify this very strange-looking marine plant, because it didn't look like anything they'd ever seen before. Louis came and had a look, and he said, yeah, that is very strange. He looked for reproductive bodies on the plants, as one does. And he found no evidence that any of these plants were fertile in any way. Irish moss typically is attached to rocks with a holdfast, as most macrophytic marine plants are. This one had no holdfast. And it was anchored to the bottom by clumps of mussels, and attached to those mussels by the mussel's byssal threads. So there is no part of that plant that sticks itself to the mussel. The mussel grabs them and sews them together and holds them down on the bottom. And in return, the plant kind of provides the mussels with a bit of buoyancy, so in this muddy-bottomed estuary, they don't sink in the mud and smother. There is no possible reason for either of those species to be in an estuary, a soft-bottomed estuary like Basin Head. It's just no fit place for mussels or moss. But together, they manage to hang in there. So here we see our giant, bubblehead on the left-hand side. This is in full summer growth, early summer growth mode. And on the right, you see what the Irish moss looks like if you pick it up off the shore. And this is summer moss too. And in the summer, in the open water, nitrogen gets very, very depleted in the summertime. And because red pigments are expensive to construct, the moss on the outer shore typically just bleaches green, and sometimes the tips even go white in the summer because they don't have enough nitrogen to build red pigments. The moss in Basin Head, because it is a eutrophic estuary with abundant nitrogen in the water all year round, the plants maintain that rich, dark, purpley brown color all year round. When the preliminary genetic, the plants were analyzed to see what kind of carrageenan they contained, because Irish moss as a genus is a commercially important plant because it has this gum in it called carrageenan, which is used very widely in textile manufacturing, welding rods, especially processed food, and also cosmetics. And they found that all of these plants had the type. There are 3 different kinds of carrageenan, and one of them is typical of females, and all of the plants that they analyzed were female on the basis of the type of carrageenan in France. No males, no tetrasporophytes. Now this is a red algae. You typically have males and females. The fertilized egg grows as a parasite on the female plant, and that produces spores. The spores settle and grow into haploid tetrasporophytes. The spores from those tetrasporophytes diploid tetrasporophytes divide by a process of meiosis, producing male and female spores, which then are dropped into the environment and settle on the bottom, and if they find hard substrate, they cement themselves down, grow a hold fast, and then put a frond on. That's a typical Irish moss life history. These gals were having none of it. So, at Fisheries and Oceans, I made a point of going out and collecting as many from different girls as I could manage. And then I went to half a dozen different outer coastal sites as well, all around PEI, including up in estuaries where there were plants that were kind of broad. I mean, that's a very classic thing for seaweeds to do. If they're growing in sheltered waters, they get kind of broad and you know, luxurious, whereas out on the coast where they're getting pounded by waves, they tend to be like tough and skinny and, you know, try to reduce the potential for being swept off the rocks by waves. They want to be more, you know, hydrodynamic, whereas these girls don't care. They never get hit by a wave, nothing ever, you know, they fragment voluntarily. And that's how they reproduce, it's just by fragmentation. And so we found 5 different, slightly different genotypes among the giant moss inside of Basin Head, and a big, wide array of genotypes that were quite different in the outer coastal plants. We, I hope, I have you know, been requesting DFO, and we've lined up Stacey Kruger-Hadfield down in the States, who has a genetics lab and does work with seaweeds, to have another look and see if she can tell us whether the giant moss is a pre-glacial relic, like it was here, you know, prior to somewhere in the Gulf, you know, pre-glacially, and then somehow survived the glacial period, as many algae did by finding a polynya and then just kind of hanging in there, or whether it's a post-glacial immigrant from Europe or Greenland or Iceland or somewhere across there, because after the glaciers retreated, Irish moss did hop from island to island and reestablish itself in Atlantic Canada. But when you look at the plants in the Bay of Fundy, there are 2 kinds, pre-glacial and post-glacial. So some plants did survive here during the glacial period, and then a bunch more hopped over and recolonized the area after the glaciers retreated. So back in 1980, when the province started to get, you know, do serious surveys, because there were people harvested, as soon as that moss was found, and they were all female and had double the carrageenan of anything anybody had ever seen before, instantly commercial harvesters started to come and haul moss out of the estuary. In 1980, the province and Paul McCurdy from Acadia University did surveys in the Northeast Arm. They found the bed containing these mussel clumps with giant moss on them extended 1,100 meters through this end, this long, narrow end of the estuary that we call Northeast Arm. And associated with those moss mussel clumps was an extremely rich diversity of benthic organisms. You know, worms and snails and crustaceans and all sorts in the sediment and on top of the sediment and in among the fronds of the plant. And not just very rich in terms of by the number of species, but the density of animals per square meter was of any individual species was in the thousands. So extraordinarily productive system. Now, subsequent commercial harvesting and also extractions made by the provincial government themselves, because they recognized this as a potentially valuable commercial resource and they wanted to see if they could get it growing anywhere else. So they took truckload and dumped it in the nearby South Lake, and they took truckloads and they put them in the Hillsborough River and Tracadie Harbor and just all kinds of places around Prince Edward Island, none of which succeeded. And I don't know, I presume they took the whole clumps, the mussels and the moss. They're not explicit as to what they did. But if they only took the moss, then the moss would have just drifted out to sea, sunk to the bottom and died. Because it leads the mussels. Anyway. So we had 100,000 pounds there. Over 2 decades, 100,000 pounds were harvested. I've added them all the records of commercial harvesting. So over 20 years, they extracted as much biomass as was there initially. The whole works. But of course, I mean, the plants were fragmenting and young ones and the mussels were reproducing, and so there was still some left. But you can see that, you know, what was a contiguous bed of these very large plants, like 40 centimeters high, clumps and moss, and cheek by jowl, except for some little patches of eelgrass that grew in amongst it, just thick on the bottom, for 1.1 kilometers. So the local people in Surrey, I mean, it was like, those guys, they're not even from here, they're coming here from Take Bloody Dish and taking our moss, and they're going to drive it extinct. We have to do something about that. So they organized a committee and they lobbied the province and they lobbied the feds, and they got harvesting banned. Harvesting of Irish moss banned in 1997. And then they kept on, they said, well, that's fine, but it needs more protection. And they started talking about a marine protected area. DFO got on board, and by 2005, they had a marine protected area established that encompassed the entire lagoon system. Now, the highest level of protection is found in that long, narrow arm where the Irish moss lives. So here we have it. You know, so this is the whole system. The entrance, the sea comes in and out here. That's the main basin where the deepest water is. And then you have this long, narrow, shallow arm. Goes right up to Elliott's there. And you can see that zone 1 is orange, and that encompasses the entire, what used to be the historic Irish moss bed, plus some area to the north and south. In 2001, a formal monitoring program was established by Fisheries and Oceans. So they were taking weekly water samples from the streams and from the estuary, and measuring temperature, nutrients, salinity, oxygen, and turbidity during the summer field months. They weren't going through the ice and doing it in winter. But they did an annual Irish moss survey. Initially, there was enough moss that they could fly a little airplane over, take photographs, and photogramically determine the area of cover of the bed. They did that until 2010, at which point there was so little left they couldn't and so much alpha in the estuary that that's sea letters, they couldn't distinguish what was moss and what wasn't. It was too fragmented. They started, David Cairns with fisheries started doing with wading surveys in 2011, where we would actually wade back and forth across the beds, counting and measuring every individual plant, because you could do that. There were so few of them. And we did that comprehensive survey, finding and cataloging every individual plant in the system up until 2016, after which we established a planting program, and or by which time, and then we selected permanent survey transects that encompass 10% of the population in each bed, and just surveyed them in the years after that. The permanent transect sampling was not really satisfactory, and at the moment we're, as you will see later, and we've got drones. Surrey Wildlife now has drones. They can do very close-up pictures under the right conditions, which are rare but possible. And we're hoping that we can get back to doing comprehensive surveys by doing it photographically with drones, and then working with computers to identify where all the plants are and how big they are. So this monitoring program evolved as needs changed and technologies changed. So, I mean, it used to be, scoop water out of with a gloved hand and take your salinity measurements. Well, now we have automatic loggers that sit in the water all year round and measuring things like salinity and temperature and oxygen level and so on. And you can go with your cell phone and gather the data off of them and throw it into your computer. It's a completely different world from what it was when I started. The Community Aquatic Monitoring Program, CAMP, which the Southern Gulf of St. Lawrence Coalition for Sustainability runs in estuaries all around the Southern Gulf, has a monitoring program in Basin Head, for which we are very, very grateful, because they're the ones who were sampling biodiversity ever since about 2001, I believe they started. So they have the same net. You just encircle an area of the arm and pull the net in, dump everything moving into a bin, identify the species, count how many of everything there is. Now, sadly, despite the protection of a marine protected area, the moss bed continued to decline. By 2014, when I went in to do an ecological assessment for fisheries and oceans, 99.9% of them were gone. 100% of the eelgrass beds had disappeared. It was mostly just bare bottom and a very occasional moss mussel clump. 224 of them, to be precise. One of the reasons for the continued decline was that European green crab, Carcinus manus, or the carcinoid menace, were first detected in Basin Head in 1998. We think it came across on one of the rigs that came over from Europe into the St. Lawrence around that time. This is a very prolific, rapidly breeding, hugely aggressive predator of shellfish, disturber of eelgrass. It just digs through eelgrass roots and chops them off. So that loss of juvenile mussels year after year after year, plus the normal aging out of the elderly mussels that just, croak, die, meant that the moss did not any longer have a dependable number of young, newly recruited, healthy mussels to throw out those specific beds and catch their fragments as they went by, because they only reproduce by fragmentation. So under the stress of heat and high nutrient loading in the summertime, the girls tend to fall apart, especially the biggest ones, and all those fragments go floating away. But if there's no mussels to catch them, they just go out to sea and die. This is the CAMP data. You can see that CAMP sampling in 2004 on the left, there's a whole bunch of different species there in 2004. And by 2014, on the right, it's just bare sand shrimp dominated bottom with tiny numbers of all those other species, often zero. So since I did the status assessment in 2014, we have been paying more attention to the nutrient loading from the streams around Basin Head and the ulva blooms, the sea lettuce blooms that dominate the top of this estuary. Because we did experimental work it's very difficult to do experimental work. Usually when you do the experiments for marine organisms, you have to kind of confine them in a cage. And that works well on a rocky shore where you can screw it into rocks, and in a sediment-loaded muddy estuary like this, every cage you put down fills up with mud pretty quickly. So you have a very limited period of time. And we tried suspending the cages from buoys in the water column and all kinds, and then we took the cages off and just suspended them in mussel socks. And they still filled up with dirt, but we did get some information about interspecies interactions and so on. Confirmed that, yeah, green crabs eat mussels, and they mostly eat the juveniles. But if the older ones, if they are heat-stressed and gaping, they'll eat those ones too. We looked at the chemistry of the sediments that accumulate in Basin Head, and the patterns of accumulation and erosion, because sediments pile up, and then you go out there. There's a very, although it's not as active as an open sea, there's daily tidal flushing. The current speeds do get fairly high for short periods of time. Sediments move all the time. They get captured in little pockets and holes. But you can get, loose 40 centimeters of sediment in one storm surge. Or you can get an equivalent pileup of sediment in a completely different place. And so we did this monitoring from specific sites all up and down the estuary, both muddy and sandy, over a period of a year, to see what happened in all the seasons. And it's very fluid. And then we looked at the chemistry of those sediments, the sandy ones and the muddy ones, and they're quite distinct. We looked at the erosion rates from the fringing salt marsh, because we could see that the salt marsh was dropping sediments and great lumps of sod into the estuary, which also smothered the clumps. We did some biodiversity transects looking for those thousands of species of 67 different categories, but we only found 6. 1 or 2 per square meter. We looked at how these clumps were moving around, because they do move, and how many disappeared. We had them all tagged, and numbered, and how fast the moss was growing, and when it fragmented, and to what degree. We looked at how crabs and mussels and moss interacted in cage experiments, and how oysters, and mussels cooperate, and all these different things in the estuary. We looked at what happens when moss and mussels are inundated with silt. The cage experiments told us that in very dramatic form. They die really fast. And then we looked into restoration techniques. Tested, well, if we were going to manufacture a clump, how big would it have to be to stay put? Where could we plant it and have it survive? How much moss has to be on the clump? Those kinds of things. We started doing drone-based photography. I got Perry Williams in there in the fall of 2014, which got David Cairns all excited, so he had his own drone, which we flew into trees, dumped in the water, and had all kinds of excitement with until we figured out how to make the darn thing stay on course. But David was brilliant. he could put together the photo mosaics and turn them into maps on which we could then GPS all of the individual clumps, and then we could map them. When we started planting clumps, then we could know exactly where they went, and then when we went back to look for them and see if they were there or not. When they disappeared, they mostly disappeared over winter, but they also moved around a lot in the summer. So all of that work involved DFO scientists, university faculty and grad students from McGill, UPEI, and Dalhousie universities, Surrey Wildlife field crews, and community volunteers. And there's some of those fabulous faces. There's David Cairns with his hat on. There. We've got Island Nature Trust folks down here. We've got Dalhousie crew doing stream monitoring. And oh, this is Madeline. This is the young woman that I trained to take my place. She now runs the joint. So, to do our work, we launch our canoes where that canoe is, at the bottom of Robertson's Field. And it's right, see that white spot there, that's a clam bed, which in 2014, every time we went by there at low tide, was spurting, fountaining madly. They don't spurt and fountain anymore. They haven't done for some years. I fear that clam bed may have been ravaged by the green crab, and it's now extinct. That big collecting plant site is what we call main bed. That's where we found the bulk of the 225 clumps that were still in the system in 2014. And then that other smaller hand up there is another tiny bed. And we call that place Corduroy Road. You can see how narrow it is. In the old days, in the early 1900s, there was fish shacks. The entrance was up there of the sea. There was no entrance to the sea down here. And the fishermen had their shacks on the beach, and they would just run their boats, fishing boats up onto the beach. And then haul supplies and fish, and also bring livestock over to graze on the dunes, using a corduroy road that went across that part of the estuary that we call the Corduroy Road Mossback.
Irene, where is that in location, the Basin Head Fisheries Museum? Is it?
Fisheries Museum is right here.
Oh, okay. So that's the run.
And this is the Singing Sands Beach.
Right, okay.
Yeah, and that's the run. That's where the wharf and the
People jump
harbor.
over the bridge.
And that entrance was constructed in 1936 at the behest of the fishermen who wanted into that basin as a safe harbor instead of running their boats up on the beach. So they took a big dredge in at the top, which is it's all closed up. There's no water, no ingress at the top at all anymore. The dunes have sealed it off. But they brought in a giant dredge and they clawed their way, dredged their way right through the moss beds, dumping moss and mussels and mud and everything on both sides of the estuary, all the way down into the main basin, and then dug, this is all new. They dug through here and all the way out to sea, and then put a wharf and stuff here. And,
Isn't there still an actual run further east, though?
at the top, no. There's no water comes in at the top anymore at all.
I walk up there, there's something up there, it must not just connect.
Well, you can see it goes all the way up to Robinson. I mean, if you go along the road to the little country store there and go down the lane, you'll get to the far end. And you can drive right down there and then walk over the dunes to get onto the beach. But there's no seawater coming in. There are streams coming in from the land side but no sea entrance at the top anymore. And unless you're thinking of South Lake,
I guess
which
it's
is the next.
about another 10-minute walk from Bothwell,
Yeah, that's probably South Lake entrance, yeah. They used to be connected. Basin Head and South Lake used to be one big, and McVeighn's Pond used to be all one system. But the sand filled it in and separated them into three different water bodies back in the 1800s. Okay, so the status was we only had 5 square meters of moss altogether, added them all up, 225 plants. There were very few mussels left in the system, very few oysters, and the oysters were all this big, and the mussels were also very big and encrusted in barnacles and just on their last callops, I guess. There was no sign of any juvenile mussels at all, and all those other species had mostly disappeared. Green crabs were everywhere. I lost a word there. And alga blooms, this is the top of the arm here. This is up in the Corduroy Road area, and it's even worse, it's even worse further in, just dominated by sea lettuce, these alga blooms. So one of the management responses that we got onto right away was to attempt green crab control. You remember those really snowy winters of 2014 and 2015?
Mm-hmm.
Each one of them sequentially killed 90% of the crab population. We know that from the camp data, because they were doing the same surveys. So 90% of them got wiped out by the spring freshet, because they don't like fresh water very much. Irish moss and mussels, they don't care. They can sit in fresh water for weeks and survive, but green crabs cannot. So those big snowfalls and the subsequent flushing of that, especially the shallow upper estuary with fresh water, killed the green crabs in the winter of 2014. And then 2015 was even more snowy, and 90% of the remaining crabs got knocked back. So we thought, aha, we have an opportunity. Can we keep green crab population down at this level? Then there might be a chance of repopulating the mussel population. So we started crab trapping in 2016, and massive. But the crabs are so there was still a population explosion of crabs. In 2022 alone, Surrey Wildlife was out there with 30 crab traps on 56 days of the year, and they pulled out 146,000. I think, yeah, it's just ridiculous, the number of crabs out there. They're everywhere. They're nipping your toes and scurrying around and burrowing and carrying on. So another management response was eelgrass restoration. So DFO gave Surrey Wildlife some money, and they actually established some 10 by 10 meter plots of juvenile eelgrass, because eelgrass was all gone, and the elderly people used to say, well, the eelgrass was so thick up in Basin Head that a boat trying to go up the arm would get tangled up with his propeller and stopped, and you'd have to send somebody in the water to cut it off. That's how thick it was. And then it was done, right? So, and they used to be able to take fishing boats right up to the top of the arm, like lobster fishing boats, proper fishing boats. You can't even get a canoe up there now. Anyway, so we planted these eelgrass patches, and then miraculously in 2017, we noticed, well, in 2016, I had noticed like 3 tiny little eelgrass plants at the bottom of Robinson's Field, because that's where we go take the canoes by. That's a good sign. So we did the patches, and then in 2017, suddenly, there were little baby eelgrasses coming up all over the place. There had been, eelgrass reproduces when it's stressed. And this wasn't just in Basin Head, it happened in Surrey Harbour and all up and down the coast. Something stressed the eelgrass population. They produced masses of reproductive propagules. Some of them got swept up into the arm, and suddenly we had eelgrass planting itself. And they were doing really well, and we were measuring and monitoring them since 2017, and then last year we went out and they were all gone. And we don't know why, but up at Corduroy Road, where the eelgrass patches disappeared, the mussel clumps were also almost completely covered in dirt. Not the slimy anoxic silt comes off the algal beds, but good agricultural soil that got king, because they're in, well, I'll get to that. You know, they're anyway. So we lost, the response to the loss of the moss was we started a clump making restoration project, and that was in 2015, like a year after I started. We were into that already because it was so urgent. So what does that mean? Well, fortunately, back in 2008, one of the DFO field scientists had the smarts to collect some samples of the giant girls and take them to Nova Scotia and get them established in land-based tanks, flowing seawater tanks, in the Sandy Cove research station there on the shore. And they're grown in isolated tanks because they don't want, it's not native to Nova Scotia, they don't want it escaping, you know, it's not a flow-through sea type thing. Anyway, they're happy, they grow real well there. And NRC sends us a tub of them, about 25 kilos every year. And then we go to the mussel industry in PEI, and Confederation mussels down in Len Curry has been a stalwart supporter of this project from the get-go, and they donate truckloads of mussels that we then depurate, which means we put them in a tank. We run cold, fresh water, used to be from my well, through the tank for a full 24 hours. And I was so worried the first time we did that, until I went back into some literature from 1850 where people had tormented mussels for like 3 weeks in fresh water and they survived. But I was convinced that they were going to die. No, they're not going to die. And so I was up all night, like, looking at them, and not only did they not die, they swam around. Anyway, so that was good.
So why did you have to do that?
Well, because we needed a source of mussels.
But why did you
Oh, because we don't want to, there are nasty invasive species infesting most of the bays that we harvest commercial mussels from around Prince Edward Island, and we did not want to introduce any of those into Basin Head. So then you take your mussels, you go to the plant, you get them in bag, load up bags of mussels, you haul them, you depurate them overnight, and then they go on long lines on the bottom, on hard sand down at the bottom of Robertson's Field, where we can haul them up and use them for making clumps. So we experimented with log-shaped clumps and round clumps and clumps with different numbers of, And so we came up with we need at least 20 mussels, preferably 50, and a small handful of Irish moss will do. We wanted to spread the Irish moss out as much as possible. Give them all lots of space to grow. We added oyster shells in the bottom of the bag. When you put oyster shells, and then you throw mussels in the bag, and then you throw moss on top, and you hang it in the water, and 72 hours later it has turned itself into a nice round, coherent clump with oyster shells in the bottom. And the oyster shells are really important because they are like a little platform that holds the whole thing up. And we learned that from studying what was left of the plants in the system. And then plant them on suitable bottom, and it took us a while to figure out exactly the limits of that was. It had to be clean, hard sand. We didn't ever want to put them in mud, but then the current speed is also important, the depth is very important. And so over time we figured this out, what is suitable bottom, and where is it in the estuary. That was a whole other project, like mapping outside of the existing beds to where we might, continue planting if we ran out of space. We monitored retention and development of the clumps and the plants, and made adjustments as we went along. So when we get the moss from NRC, we put them into mussel socks and suspend them from buoys, and they grow like stinko. They get really big. And, you know, this is kind of the team at work. We've got some manufactured clumps here with oyster shells on the bottom, and got people hauling them out and planting them in shallow water at low tide. Just checking them out, just to make sure they're coherent enough that they're not really bound together tight and put them back to hang out together for a little while longer. And then, yeah, and then, you know, surveying the beds, and we had them all tagged and numbered, as I said. So as the numbers of clumps increased, of course, the cover of Irish moss increased from that initial 5 square meters to 182 square meters by 2021 was our best guess. By then, it was that there were thousands of clumps in the water, and we couldn't actually, you know, count and measure every one. So we were taking those initial comprehensive surveys up to 2017, and then adding the number of clumps planted and subtracting the percentage loss that was seen on the survey swaths, and coming up with a sort of a general ballpark number of what we thought was out there. And this is one of David's photo mosaics on which we have mapped the clumps that we planted in, I think this is 2017 and 2018. That's main bed. So, green crabs were a factor, and they continue to be a challenge. The other challenge that threatens this whole episode is land use. As you know, agricultural nitrates, pesticides, and eroded soil flow bleed into the sea from agricultural lands all around Prince Edward Island, and they cause fish kills in rivers and massive algal blooms in estuaries and anoxic events in estuaries all around PEI every summer. Those are eels that were killed in the Southwest River in 2004. I didn't think anything could kill an eel, but we managed to with our land use practices. Now, land use in Basin Head, a watershed, is dominated by potato agriculture. So the dark, you can see the dark forested areas, and then all those kind of regularly fields in different colors are all in agriculture production. Here's the arm. You see all of these fields here. The majority of them are in potato rotation. So, and the majority of the potato farmers are growing the Russet Burbank variety for Cavendish farms. Russet Burbank has to grow very big to make those long French fries for McDonald's. It needs a very long growing season. It is extremely inefficient in taking nitrogen out of the soil. No matter whatever amount of fertilizer you give them, they'll only absorb 40% of it, and the rest goes into the estuary via groundwater and streams. Because you need a very long growing season, the farmers plow the fields in the fall so that they're not held up by having to plow in the spring. And then they don't harvest it until late in the season, which means there's no time to put a cover crop on those open fields the next year. So in a 3-year rotation, 2 winters, the soil is bare. Nothing to hold it back from running into the estuary. So massive nitrogen loading results in these blooms of green algae, mostly Ulva lactica, but also Enteromorpha and Chlodophora and other filamentous species. These like smother the bottom. If you get landed on by a big pile of Ulva, it gets anoxic and you die. So the rot, and then these algal blooms rot and go white. So at that point, when they're white, they've liberated billions of spores into the estuary for the next generation of algal blooms, and generated create silt that streams downstream. You can see it coming down, streaming down through the estuary after the collapse of an algal bloom. And then that silt settles on the bottom. Before we do, I mean, this is what we did for years. Before we could even do a survey, we had to haul the alga off the bed so that we could find the clumps. This is what an anoxic event looks like. It looks like milk. No oxygen in that water, and everything's dead except the alga.
Irene, there's some water behind on the, I left it there
Oh,
for you.
thank you. Yes, yeah, that'd be good. And there's the silt, and in some places it's up to here. So I've given up fieldwork in Basin Head because I'm 70 and I can't do that anymore. It's acidic and anoxic. We've measured it, done the chemistry on it. And here's eroded soil from Robertson's field cascading over the banks. So 2 out of every 3 years, that's what's going on from the majority of farm fields. And both the provincial government and Surrey Wildlife are doing research with farmers. Well, Surrey Wildlife, under my direction, first did this research with farmers. We went out and interviewed I think 11 of the big native farmers in the watershed, and asked them to tell us, what's their rotation, how much fertilizer do they use, how much pesticides, when they're applied. And they were very cooperative. They opened their books and let us see all of their data, which was great. And now Surrey Wildlife is working with them to try to mitigate the soil erosion. I mean, those farmers, once they knew the scale of loss, nobody wants to lose soil because that's money. And they've also done some wetland restoration in the watershed, so to clean out and restore, little ponds and bogs that are surrounded by farmlands and had been filled in with soil, and try to reestablish, sediment catching wetlands are very, very important. When we do surveys, whenever we survey the moss on these permanent transects, we measure the thickness of penetrable or loose sediment on the top, and the Irish moss cover, as well as the ulva, the sea lettuce cover in the beds. And we're taking samples from the streams entering the estuary, measuring the amount of dirt, soil, and that is continuing to come down through the year. We're doing that with Dalhousie University. The other area of concern was the marsh edge. So there's salt marshes fringing the estuary. And you can see it's rapidly eroding, especially in recent years, because these stupid, since 2015 we haven't had a proper winter. It's just freeze thaw all winter. And what that does is it cracks up the marsh. And then you get these big lumps that crack off the marsh, and then a storm comes in and they move away and they land on sometimes in the middle of a sandbank where the moss is, and kill everything. And then what's left just slowly degrades and erodes, and all those fine sediments and organic materials go into the system and exacerbate what's coming from the other side, from the farm fields. So very, very challenging place to work. We've been measuring marsh edge erosion. That used to be 30 centimeters from the marsh edge, and now it's on an exposed face. So we had these, iron rods up at Corduroy Road and at Main Bed, all along the edges, and in the large sods that were sitting in. We want to see, how fast do they decompose, and where does that sediment go, and is it different from the sediment that's coming from the ulva or from the farm fields? And we did all that, soil chemistry analysis and stuff. Anyway, one of the things we discovered that, in recent years, even the short time that we've been measuring it, marsh edge erosion has doubled, and that is because we're not having proper winters anymore. They can be as high as 170 centimeters a year, which is a big chunk of marsh. Yeah, that's what David Cairns called Tyrannosaurus Point, because it was a lovely point and had a dinosaur-like mouth and an eye in it and everything, but the whole head of the dinosaur is gone now. So, so these warmer winters are a problem. Not just because of the erosion of the marsh, but because instead of having a solid sheet of ice all winter, like from early January through March, you get this stupid thin ice that cracks up and moves around, and then some of the lowest tides of the year are in January. They hit the bottom, and then they get pushed around by the tides, and they obliterate clumps and push them off the high sandy banks into deeper water where the mud is thick. Eesh. So our permanent transects give us an idea of what the annual losses are. Most of them happen in winter and in any part of the transect that is anywhere close, like within a few meters of a pocket of muddy sediment. So, you know, our planting strategies have refined. I mean, we're really careful about where we put those precious clumps, and we are actively looking elsewhere in the system for suitable shallow sandy banks. A lot of them are outside of Zone 1. So that needs to be rectified as well. So here's your plantable bottom, firm shallow sand with eelgrass, patches, and oysters. Downstream of where the main beds are now, because the current speeds are better down there. And Irish moss likes a nice current, doesn't really like stagnant water. And because in Zone 2, commercial fishing is allowed, in fact, for oyster harvesting and recreational fishing. So we need to extend Zone 1 to the far end of Northeast Arm so that we can continue to plant down in what looks like the best bottom we have. And that's going to be a fight because there are two oyster harvesters who really like fishing in there, even though it is officially polluted water because of the septic inputs from the Fisheries Museum and so on. The bacterial loads are unacceptable, and they presumably take them somewhere and depurate those oysters before they sell them, but we have no control over that. So anyway, that'll kick them out, and there'll be a big uproar. Look forward to that now that I'm gone. Enough uproars in Brunel. Okay, so as we move planting activities downstream, we know that the water is cooler and the sediment is more sandy and less muddy. And Barrett Kurlick from Dalhousie has been doing hydrological surveys, and his drones are so fancy that they can do thermal reads. So they tell us where these dark purple where springs and seeps are entering from the bottom, you know, as opposed to the streams we can see visibly. These springs and seeps that are coming up from the bottom are also very important. And knowing where those are, that means, well, that water in that area is cooler. We don't care about the salinity because Irish moss and mussels are euryhaline. They can tolerate very low salinities, very high salinities. Much better than green crabs can, so that's a good option. Now, so the warm winters are a problem. The increasingly hot summers are also a problem. Irish moss and mussels have a really wide temperature tolerance, but really after 28 degrees, if that goes on for days at a time, it will kill them. And that's very typical of northern Atlantic temperate to Arctic species, which these are part of that group. That their upper threshold is around somewhere between 26 and 29 degrees typically. Our shallow waters, you can see these maxima, and this is in main bed. Corduroy Road is even hotter. The summer water temperatures, the maxima are hitting 30 already. That was just 2011 to 2013. 2012 was a stinking hot summer. That's when we had 20 degrees in March. But it never happened since. But if I put that thermal trace up for you now, you would see that the average is approaching the maximum. And so the management approaches just have to adapt to this reality. And one of the responses is to move the plantations further south where the water is a little bit cooler. We also have an increasing frequency and intensity of storm surges and a rising sea level. So of this offshore dune, its lowest point is where the old sea entrance was, up above Corduroy Road, beside that little road that goes to the corner store, or it's another country store. And that is the most likely place for a rising sea level combined with a storm surge to break through the dunes. So at some point in the future, we will have a system that has an ingress and outflow at both ends, and that actually, at least on a temporary basis, will probably be good. It will increase current speeds, water flow, and the degree to which cool water can get up into the top of the estuary where the moss beds are.
Make a little island.
But eventually the dunes will erode away completely, and that's a whole different story, but that might be probably 100 years. Whereas the breach is most likely in the next 20 or 30 years. So drone-based photography has been a key technological aid, and Dr. David Cairns is responsible for that, and Perry Williams for the inspiration, for developing these georeferenced maps, where we can map out everything that we do, where we can map out the potentially plantable habitat, and do planning and monitoring for the restoration. And the question we're grappling with now is that, can we actually locate and measure every clump using a drone and computer? And so David Cairns again started that work. He's now retired, but Surrey Wildlife now has techies on staff who are very keen to, boys with toys. Drones, computers, maps, hey! So that's lovely. So for example, this is a drone image taken at 6 meters altitude, a low slow flight, and we can get an image like that by blowing it up. You see the purple shadows? They're cast by moss. It's very interesting. I just find it delightful that this purple plant casts a purple shadow. It's different from what you see if it's just oliva. Now that whole thing is a moss clump, but it's covered in oliva. And then there's other little moss clumps around it. So you can make a circle of that with GIS, and then add all your circles up and come up with an estimated cover, Irish moss cover. So in conclusion to this, the giant moss is not yet extinct. First of all, because community concern drove government regulations and stopped the commercial harvesting, and then attracted DFO to put a marine protected area, which brought in more resources for research and monitoring and management and stronger protections. The annual monitoring system detected the massive decline. Research projects, often involving university students, identified the threats that were causing the decline, and some some of the requirements that these various species had for survival, and then this whole system of adaptive management where we've switched up our game, and we just haven't been enamored of any one thing. I mean, we don't do something and then think we have to do that exact same thing forever, which is typical of scientists. They love to do that, but not appropriate here. You have to admit your failures, switch it up, and try something new, and get on with the job, because this is not just science. And further adaptations and management are going to be required, especially as the climate changes. Because we can get a hold of farm practices and soil erosion and those things. We can't do anything about the climate except adapt and adjust. This is the official DFO management plan, and I will not take you through that because I just want to point out, before you get too terminally depressed, that we are not alone in this fight. Mother Nature is on our side. There are natural processes that we have already identified and know that are helping. We've been sold this bill of goods that nature is red and tooth and claw and it's all about competition and predation and herbivory. But that's only a fraction of what actually goes on out there. There's also interspecies facilitation and commensalism and cooperation and mutual support that is happening among species out there all the time. They are very interested in their own survival and actively working towards it. Now, we know that Irish moss and mussels will have some inherent genetic capacity to adapt. I mean, I've done a lot of research in this, and I have found that in the other plants you can have as much as a 2 or 3 degree difference in the upper thermal tolerance of plants that are coming out of different more or less stressful environments. We haven't actually measured the thermal tolerance of the big girls, but I have asked DFO to do that, and I think we're finally going to get along with that. Mussels are more of an issue because whereas the girls are perpetual, they've been there for Lord knows how many hundreds of years, the mussels are being recruited on an annual basis. And they are less likely to be able to adapt. But the girls should be able to, maybe they have already. But we really need to understand and support the ways that the various species in the estuary are working together to save themselves, so that we don't get in the way. Because we could easily go and adopt a management practice that discouraged or eliminated the positive stuff that the natural systems are doing if you're not very careful. So that's the end of that story, and I don't know what time it is, but I wonder if you were interested in hearing Irené. Alex Villanueva was a British undergraduate who visited and was inspired by Basin Head. As far as I can tell from her CV, that was back in 2013. So just before I never got to meet her. I arrived here later. And it's called Oeuvre on the Desires and Inclinations of Basin Head's Chondrus crispus. You ready for it? Okay. I was inspired to include this poem in the whole thing by a grade 7 Birchwood intermediate school class that I took to the shore last week, which was fairly well dominated by 12-year-old boys. And we were looking at seaweeds, and as soon as I started saying, swollen tips and succulent bits and oozing gelatinous substances and anthrozoids and eggs and things, they were like it was all about the sex. They want to know, how do seaweeds have sex? How do they communicate? How do the sperms find the eggs? What? How? Tell us, and say all those juicy words, those botanical words. They would just giggle, 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 giggle. And the girls were in the background going, it was delightful. We had a lot of fun. Okay, so, dedicated to the 12-year-old boy in all of us. Chapter 1, the dance. Mid-uliteral, we float, and this is in the voice of the Irish moss. My siblings and I, wedded to muscles blue, adjoined in bissel lace, in buoyant phototropic dreams, we dream of our open-watered cousins, slender and spore-sexual, in delicate robes of dichotomous branching, while we content ourselves with broad, flat fronds. Each season my cousin blushes a different color, red, yellow, green, encrusting and encrusted to precious rocky substrates. Life is different out here. Out there, salinious, kinetic. In Basin Head, lagoon life is suboptimal, they say. Too hot, not salty enough. Yet here I sit, fleshiest bit, rotund even, weighing a wet half-kilo. Dancing a deep purple tango with a sweet, depressed mollusk. Mitose, edulous, a dulcet name for soft, unsegmented body. Mole. Cocooned in a calcareous shell, elsewhere sessile and bedbound. Here, my anchor, my mainstay, she dances in my skirts and clings to me tightly, filtering our waters for a bite-sized snack, and there are times when my fronds brush up against her protruding siphon, or my thick purple flesh slips into her unlatched shell. Her statusists tell her I'm here. She feels me more than I feel her, and we dance, bobbing along the mere sludge bottom. Chapter 2. The green crab. Emerald pincers on a thick carapace, exoskeletal cutlery for inquisitive probings. She maps diagonally Basin's Head estuary, Carcinus manus, carcinoid menace, the colonizer, invading the flesh, the tight space between shell and plant cell, tangled in our fabrications. Her nippers clamp open the muscle shell, mandibles sucking on succulent flesh, on the tender yellow mantle, nestled within. Delighted and delighting, entwined in this predatory caress, the pair sink, and I with them, a triad of corporeal relish. In this knot, the crab savors my flesh too, gelatinous aftertaste. Clunky and gauche, claw cotton mesh, she pulls on threads, unravels the threads of the bissel weaver, and with this I am released. I slip, I glissade on the evasive edge of where air meets water, meets sand and song. She joined the dance some 17 springs ago and found it so jolly that she decided to stay. In 10 years grew to a 70-fold sum, some voracious predator, trapezoidal, not predating our symbiosis, my muscle and I, but becoming part of something different. Chapter 3, the bloom. There have been springs when the green was too sage, too verdant. Our fronds, below the runny veneer that pulsed towards sunlight as days go longer, phytochromatic fixation, no longer felt flickers within, for chlorophyllic bloom obscured all we knew. New tensions of disorientation, Where shall I creep and meet? To which compass point? Where's my sustenance? Alva, sweet green screen, remove your slender body from mine. Eutrophied is this thick water. I choke on sour growth and excess of nutrient, encapsulated in Basin Head's estuarine lagoon.
You gotta love poetry to capture the story.
Yeah, you do well. I could have just gone there. You didn't need the hours to talk at all.
Thank you, Irene. So we have a bit of time for questions. It's 20 after 8, so maybe, maybe 2 or 3 questions if anybody has any questions for...
20 after 8, oh my God.
I
Go
know.
on, I'm sorry.
I could have given you the hand signal, I suppose, at 45.
Yes,
Mike.
So whatever Irish moss is in the Basin Head estuary, it stays there? It's not being rejuvenated to be used commercially or
It's
anything?
not being commercially harvested, but there are losses year over year. If we didn't plant, if we hadn't started planting in 2015, it would be completely extinct by now. I'm very much convinced. Because there are losses every year. We plant thousands and we lose hundreds, so we are making ground. But in wintertime especially, the losses are sometimes whole sections of our survey swaths get just wiped out, smothered. Yes?
With the sexual reproductive style of this moss, is there less of a genetic diversity within this population?
Yes.
In turn, is there any concern of a certain invasive, I'm not sure what sort of predators against moss besides crabs. Was there like parasitic?
In outer coastal populations of moss, as I explained before, we only found like 4 or 5 genotypes in the giants, whereas there are tens. I mean, in every different population around PEI, they're all different, very different, and much more diverse. So yes, the genetic diversity is very narrow, and they only reproduce by fragmentation. There are no boys for these girls. There are males of the outer coastal form. That there are 3 rocks in northeast Ireland, and there are some old cement blocks that scientists have left behind. We've hauled most of them out now. But the moss population that's on the imported rocks from Nova Scotia that protect the harbour, there's a little like outer coastal moss population there, and their spores get entrained, and where there is a little bit of hard sediment, they do settle and grow quite happily and reproduce, male, female. But none of the males gets these giant girls excited at all. They just don't bother. They do not form cystocarps. Interestingly, in Sandy Cove, in the tank culture, they sometimes see lumps on the girls, and they'll dissect them and look, but they're false cystocarps, and other members of the family from which Irish moss comes, other species do that too. They'll form false cystocarps that just don't go anywhere. They never get fertilized. But our girls don't even bother to do that. Not in the wild. I've never seen it.
Thank you so much for your presentation. Your love for the girls is palpable, and your contempt for the green crab is quite clear. So, one part of your presentation I can't stop thinking about, I found it horrific, was the experimentation done by the province once upon a time to try to recreate these populations. And what I was left thinking is, like, I can't have a focus group discussion with community members about a wind turbine without an extensive review of the ethics and the different layers of the research and the risks and benefits.
There's none of that happening in
Is
the
there
80s,
anything
my
now?
friend.
Was there anything then? Is there anything now to kind of protect the rights of nature in this experimentation? Or can you point me to a model? that you
Well,
can
they're
see?
not, that all happened in the 80s.
Okay.
And it fragmented the bed. So when the green crab invaded, instead of having like a massive big bed that they could only nibble the outside edges of, it was little patches of that former bed scattered over, so they could get into the mussels
Because
on
of what
all
the province
sides.
did, like
And
ripping it.
just pull the babies out and eat them. So I am convinced, from an ecological perspective, because there is evidence in the research that, when you, or even forestry research, you fragment a forest, you get more pests. And the forest becomes much more vulnerable to anything from a large wind to a passing, borer.
It lowered the resilience.
Yes, yes, it really compromised the resilience of the population.
So is that partly because they didn't understand the symbiotic relationship?
No, because they hadn't done any, they only started doing kind of ecological research in the 2000s to try to understand what was going on. And by then they knew, they'd already stopped the harvesting. The province and the community had already realized that that was a bad thing, and they stopped that in the United States, but it was too late. Because, as I say, the equivalent of the entire bed had already been harvested, not only by commercial harvesters, but by the province itself. It took truckloads and dumped them in randomly into various estuaries all over Prince Edward Island. To no avail. It only loves Basin Head. Can you grow anywhere else? No.
Well, next time we go to Singing Sands Beach, we'll have to take a little walk in and check out.
Don't let them look at the alder bloom.
Right, and we won't walk on the rocks, right? I want to thank you so much, Irene. This was really fascinating. I had no idea what you were doing up there, but I knew you loved it. Keep it up. So we do have a little gift of books in our PEI potato bag. I probably should
goody.
give her a book in a potato bag.
Well, as long as there's no potatoes in it.
There's no potatoes in it, it's just all about the bag.
Nitrogen absorbing potatoes.
It's proper potatoes.
Yeah, so you may have them, and we have more down the hall if you have those.
Oh,
already.
thank you. Oh, my Lord.
Okay.
Oh, yes,
Poetry.
very nice.
Okay.
Thank you very much.
I just want to thank everybody for coming. It's absolutely fantastic to see having an audience here. I want to thank Mike for doing the videotaping, and we'll be uploading it to our Island Lecture Series page on islandstudies.com, so you can spread the word, and you can spread the word that it will be there.
You
the next couple
must
of days?
you have to be a nimble lad on the camera. I was all over the place, Mike.
It's very wide angle. So this will be the end of the lecture series for this academic year, but we will restart it again in the fall, and looking for ideas for talks. I have one or two already, and so if you have any ideas, just send me an email, brainflow@upei.ca, or stop in and see me, or give me a call, and happy to chat about ideas, because these are all, we learn so much, and I just love it. So thank you again, and thanks, Irene.